Good morning and welcome to today's Masterclass, one of the marquee events of the University of Melbourne 11th Annual Science Festival as part of National Science Week. My name is Julia and I will be your host for today's Masterclass and all of the Masterclasses happening this week. As a host, I'd like to acknowledge the traditional owners of the unceded lands on which we are filming, the Wurundjeri Wurrung people. Aboriginal and Torres Strait Islander people are this country's first scientists with deep and enduring knowledge of the land, waters and skies. I pay my respects to elders, past and present, and I welcome all First Nations people here today. In making this acknowledgement, we commit to respectful and responsible conduct towards all others according to the traditional laws of this land, particularly at times of formal ceremony. Today's event is Stories, Seasons and Signposts in the Sky, Indigenous Astronomy, with Associate Professor Duane Hamacher and Ellen Tunumafono. And we are coming to you live from Science Gallery Melbourne on our Parkville campus. Science Gallery Melbourne is located in Melbourne Connect and is the University of Melbourne's hub for innovation. The gallery is available free of charge and their latest exhibition, Destruction, has just opened. We also have a few schools here in the audience today. Welcome to Mary Mead Catholic College, Alamanda College and Keysborough Secondary College. Thank you all so much for joining us. So today, how it will all work. So Duane and Ellen will be giving a 30-minute presentation about their work, and then we will be taking questions from our audience, and that includes online as well as here in the room. And we aim to finish up at 11:30. So to ask a question, for those in the room, nice and simple, you just have to put up your hand and we'll come to you with a mic. For those online, all you need to do is click on the Slido link in the chat and we'll be testing that very shortly. We also welcome all comments, but of course, please be respectful. So, to make sure everything is working online and to get to know you, our audience, and I believe there's already been a comment in the chat about this, but please let us know on Slido, where are you joining us from? Which school are you from? Which suburb? Which country? I know in the past there's been quite a few audience members from all over the world, and so it'd be wonderful to find out where you're from. So click on the Slido link and we should be able to find out. Melbourne, Melbourne, Melbourne so far. Thank you everyone for letting us know. Keep them coming in and we'll be able to refer back to that. Lots of Melbourne audience members. Wonderful. Okay, so once that's all done, so it's time to hand over to our presenters. And to start off with, I'm going to hand over to Duane.
Thanks, Julia. Good morning, everybody. I'm excited to be here chatting with you guys about some really interesting discussion topics on Indigenous astronomy. Oof, I need this, hang on. So my name is Duane Hamacher. I'm an associate professor here in the School of Physics and the director of the Cultural and Indigenous Astronomy program at the University of Melbourne. It's a pretty cool job, actually, to be involved in what I'm doing because I'm not looking so much at understanding how the stars work themselves, but what I'm looking at is how we as humans connect to the stars, how we find meaning in the stars, and how we can apply that knowledge in our everyday lives. So I'm excited to be here chatting with you on Wurundjeri country, and especially happy to be working with Wurundjeri, Taungurung, Jara, and Bunurong communities on some big projects on Indigenous astronomy guided by those communities. Now, over a long period of time of working with communities and learning from elders, they've shared a lot of fantastic knowledge that I'm going to be discussing with you today. And one of them is that the people of this land have been observing the skies for tens of thousands of years. And in observing those skies, they've worked out a lot about how the skies work. And there's going to be different applications of that knowledge. And what I wanted to do today is talk a little bit more about the navigational side. How do we find our way across land and sea by utilizing the stars? Now, one of the really cool things I've learned from the elders in the communities is that everything on the land is reflected in the sky, and everything in the sky is reflected on the land. As is above, so is below. Has anybody ever heard of that? As above, so below idea before? Yeah, a few of you, right. So this means that if you want to understand how things work down here on the land, you can look to the stars. You can look to the stars as a timepiece. You can tell time. Almost every way that we understand of telling time is using the sun, moon, and the stars. If we want to learn about seasonal change, we watch when stars rise or set at dusk or dawn. And that tells us about the behavior of the animals, about the different weather patterns along that season, about how long the sun's going to be in the sky, about the plants themselves. We can also learn to find our way across space. So we look at space and time. The concept of space is what we're going to discuss today when we start talking about celestial navigation. How do we move across land and sea? Now, it's quite a complicated topic, and I don't want to get too in-depth with it, but I do want to make it a little bit more interactive. And I think what's more important is that we have some basic concepts we can leave with today, particularly about how we can determine the 4 cardinal directions. So, what are the 4 cardinal directions? What's the first one? Just stare at me, come on. What's the first one? You might know what a cardinal direction is. Anybody? Any ideas? No idea. It's not a bird, right? Somebody? What's cardinal direction? North, right? They're the directions. Directions, just take cardinal directions, right? What's the first direction? North, east, and good, we're done. Awesome. Excellent. So what we're going to do to start off is learn how to use our hands as a mathematical navigation device. Because what we have to do is measure where stars are going to be and how the distances between stars and the distances between the stars and the horizon. Now, we do that by imagining in a coordinate system. We're standing here and there's a giant dome placed on top of us. This is the dome of the sky. And we can see everything projected onto that. So what we're going to do today is learn how to use our hands, and this is a technique that goes back a long way, used by cultures in Australia, the Pacific, all around the world to measure distance. So the first thing we're going to do is hold your arm out at full arm's length and put your little finger up. You can do it like this or like this, but this doesn't work. It has to be all the way out. All the way out. Now don't crook your arm. It has to be all the way out, right? The diameter of your little finger is about 1 angular degree. The sun and the moon are both about half a degree. So the sun or the moon may seem quite big in the sky, but when you hold your finger out, it's only half the width of your little finger. Seems odd, but it's true. Go outside and check it. In fact, we have a full moon right now, so it's a good time to go out just at sunset and see it, because the moon looks really big when it's close to the horizon. So it might seem big, but put your finger up next to it and you're going to find out. Your finger will completely cover it. Now, it's a little bit odd because the sun and the moon look like they're the same size in the sky, but they're obviously not the same size in space. It's a weird situation where the moon is 400 times smaller than the sun, but the sun is 400 times further away. That ratio means they look to be the same size in the sky. Now, let's do this. Hold your fingers all the way out like this. Now, the width of these fingers, right where your knuckles are, is about 5 angular degrees. You can try the full fist up in the air. All the way out, it's about 10 degrees. Throw your metal horns out, about 15 degrees. And then your surfer hand is around 20 to 25 degrees. That one's a bit different for everybody because some people can really spread their fingers out quite a ways. So what I want you to do right now, whether you're in the room with me now or if you're online, look at something. For you guys, I want you to look at the screen. From the bottom of the screen here to the top, using some combination of these hands, how high is this? So remember, you can't do it like this because things that are closer to you are going to appear bigger, and your hand's the same way. It has to be all the way out. So get the arm locked out. That's how far out it has to be when you're doing this. So whatever combination of things you need to utilize to figure out what the distance is from the top to the bottom of this screen. It's a bit of a fun activity, but it gets you thinking about it. So from the top to the bottom of the screen. All right, what'd you guys get? Any ideas? What'd you get? Yep.
25 and wait. And 5?
25 and 5 is?
It's because, 25 and 5, 30.
30, there we go. Great. We're all on the same page. That is for you. But what about in the back? What'd you guys get in the back? Yeah, what'd you get? 18. What'd you guys get up front? 35. 35, okay. Well, you're noticing is the further away you get, the number gets smaller, right? What'd you guys get in the back over there? 15, right? So really small back there, much bigger up here. Of course, the screen's closer to you, right? Now, when we're looking at stars in the sky, they all look like they're on this celestial dome. They all look like they're going to be the same distance away. But we're going to talk about what this means and why it's even important, right? Now, you may have seen this type of technique used before if you've ever watched certain kinds of films. The Polynesian cultures will use this by putting their thumb on the horizon and measuring how high stars get above the horizon with their hand, where their fingers, their knuckles, folds of skin, whatever it happens to be, can represent different angular degrees. This is in a very famous Disney film. Anybody recognize what this is? This is from Moana, right? So in the film Moana, they use this, and if you look closely, you can actually tell some of the stars in the sky that they're utilizing the constellation of Orion. We're going to talk about why Orion is a good navigational device in just a minute. So what we're going to do is we're going to think about how we can determine these 4 different directions. How do we find north? Well, we're in the southern hemisphere. So when we look up at the sky, is there a north star we can see from down here? No, there's not. Where I'm from in the US, yes, we've got Polaris, the North Star, which is a fairly bright star right next to the point in the sky that doesn't move. All the stars seem to move around that. We call it Polaris because it's a pole star, right? Kind of obvious. But down here, when you're below the equator in the southern hemisphere, you got to find other ways of determining north. And what we're looking at here is a really beautiful Torres Strait Islander lino-cut artwork of Bezom, the shark. So Bezom, the shark, comprises some of the bright stars in a special constellation that is very close and dear and near to me, being from the northern hemisphere. But for many people who were down in Australia, especially the southern part of Australia, you can't see these stars at all. These are the stars we in the north call the Big Dipper. They're part of the constellation Ursa Major. That's how it looks to us up in the northern hemisphere. But when you're in the southern hemisphere, you're looking at them kind of upside down. Well, maybe we're looking at them upside down up north, right? It looks like that. These stars represent a shark seen in the sky. And the shark in the sky, Bezom, tells the people all kinds of different things depending on its position in the sky throughout the year. When it rises, when it moves across the northerly horizon, and as it sets. So interesting thing, when you're in the northern hemisphere, it's a really easy way to find Polaris because those 2 stars at the end point right to the North Star Polaris, which is the tip of the handle of the Little Dipper. But unfortunately down here, that is below the horizon. You can't see it. But if you're up in the Torres Strait, which is around 10, 12 degrees below the equator, you can see these stars, but they're always towards the north, and they're always fairly low on the horizon. And the elders will talk about how as the shark rises and moves across the sky, it tells you different things. And right around this time of the year, you're going to see the nose of the shark touching the horizon just after the sun goes down, and you can see the stars pretty clearly. That's the time of the year when the sharks are breeding. They come very close to the shore because they're hunting sardines or toop. The sardines look like gray bands right along the edge of the water, and the sharks go darting through them. That water can be extremely shallow. I mean, I've been over there where the water's only about this deep. You can see sharks going back and forth in the water, where it's not just their dorsal fin, but the whole top of their body is out of the water as they're diving along. And I've also seen 7-year-old kids out there playing with them, grabbing them by the tail. Looking around, there's no parents. Very different environment up there, but the kids know exactly what they're doing. So with navigation, the elders tell us that that constellation is always towards the north, and when it's right across over Papua New Guinea, that tells us about the behavior of the shark. But those two stars represent the front part of the shark. It represents kind of the gills, because there's some little stars towards the front that represent its nose. But right where its gills are those two bright stars we can see right there. And even though north is below the horizon, the elders still tell us if you look when those two stars are straight up and down, they're pointing to exactly due north. And as long as you understand the angular difference between those stars, you can always figure out where north is. So you can utilize the stars of the Big Dipper, of Bezom, to figure out how to find north. But when you're down here, it's a little bit more of a challenge. So we're going to utilize a different technique in just a minute. What about finding east and west? We know the sun rises in the east and sets in the west every single day, but it doesn't set it due east or due west every single day. It has a range across the horizon as we go from solstice to solstice, midsummer to midwinter. It's only on one day of the year that it rises, or 2 days of the year, that it rises due east and due west on the equinoxes, around the 21st of March and the 21st of September. But we're going to look at the constellation of Orion and talk about how that can help us determine where east and west are and why that was so important to Aboriginal and Islander cultures and Pacific cultures. Well, there's something quite fascinating about these stars. They lie along the ecliptic equator, right? So they right along the celestial equator, where all the stars seem to go from east to west. Now, most of you could probably, how many people could pick out Orion in the sky if you went outside? How many of you have no bloody clue? Nobody could find Orion in the sky. They can, you guys can't? What's going on? I know it's hard to see anything from the sky when you're in Melbourne because light pollution is so bad, but anytime you get an opportunity to go outside and have a look up, you'll be amazed at what you can see. But there's a very famous little asterism, part of a constellation we can see in the sky here. Has anybody ever heard of the saucepan? A few people, right? Excellent. So the saucepan is right here, right? It's those three stars of Orion's belt and the stars of his scabbard. Trace out that saucepan. That group of stars rises exactly due east and will set exactly due west. That's why they are such a prominent navigational device. That's why they were used in Moana. That's why they're used by cultures around the world. Now, an interesting thing that I was taught by some people, both elders and non-Indigenous people, is that the saucepan will scoop up the stars in the morning because it rises with the bottom kind of flat, not exactly, but pretty flat. But as it goes over into the evening, they're directly on its side. So it scoops them up in the morning and pours them out in the evening. So they rise, the three across, and they set with the three vertical. So cultures will be able to utilize these to figure out how they go from point A to point B. Now, the thing about navigation, and what gets tricky about it, is you need to know where your cardinal directions are. But if you're plonked down in the middle of the Pacific Ocean, looking at the stars isn't going to tell you where you are. They can only tell you how to get from point A to point B if you know the route, right? But there are other ways we can work around that. We'll talk about that now. So finding south. What constellation are we going to use to find south? All right, what's the most famous constellation in Australia?
Southern Cross.
Everybody knows the Southern Cross, right? Who can find the Southern Cross in the sky? These guys are showing you guys up. What's going on? Seriously? Raise your hands high if you know where the Southern Cross is. Everybody's terrified. They got confidence. What's going on? It's on the Australian flag, right? How many national flags is it on? It's 5, right? It's 5 different countries that have the Southern Cross and the national flag. Now, the Southern Cross is understood perceived by Aboriginal and Islander people in a lot of different ways. Sometimes it's seen as a turtle, sometimes it's seen as the footprint of an eagle, or even the footprint of an emu. In some cultures, each individual star represents a character and a narrative that tells you about a story embedded within the stars. In the Torres Strait, for example, I know I'm doing a lot of Torres Strait stuff, but that's where I do a lot of work with the communities up there, and I find that to be a fascinating place. Up in the Torres Strait, the Southern Cross is the left hand of Tagai, and Tagai is a gigantic constellation in the sky. It represents a fierce warrior and a Zogoli, a spiritual man. And the elders teach us that long ago, Tagai had a crew. He had a first mate named Kareg and a crew of 12 men called the Zugubaus. And one day they were going out on a long fishing expedition, and as they went out to sea, they didn't have much luck catching anything. They just couldn't find any fish. So they went out by a reef, and Tagai went along the reef by himself to try to find a better fishing spot. And as he did that, the other crew members, the other Zugubaus, sat in the canoe, getting hot, getting bored, getting tired, and started drinking the water rations, started eating the food. Kareg, who warned them against this, his words went unheeded. And before too long, the crew had consumed all of their rations, and they had broken very traditional sacred law. When Tagai got back and he got into the boat, and as he got into the boat, he heard the coconut shells, which hold the water, rattling. They ain't supposed to rattle if they're full of water. He found out what happened, and he flew into a fit of rage, and he took 6 of the men, and he tied them together, cast them into the water, and then speared all 6 of them. He took the other group of 6, he cast them into the water where they drowned in a fit of rage. But because they were also spiritual beings and couldn't die, they all ascended into the sky. The Zugubaus became the stars of Orion, which we just talked about, and the Pleiades, called Usium and Seg. And Tagai and Kareg, his first mate, went up into the sky. And the constellations we look at now with Scorpius, which is the giant canoe. Kareg is that red star in the canoe, Antares. And Kareg is this giant constellation in the sky holding up a spear. His right hand is a constellation of Corvus the Crow, and his left hand is a constellation of the Southern Cross. How many stars you see in the Southern Cross? It's not a rhetorical question. How many you see in the Southern Cross? How many are on the flag? How many fingers do you have? Right? That's a little finger. So he's grabbing onto that spear, and he's standing on top of his canoe, a huge constellation in the sky. And as this constellation rises and sets at dusk and dawn throughout the year, it tells the people about the changing seasons. It also tells people how to navigate. So how are we going to find south using the Southern Cross? There's a few different techniques, but one, we're going to do something like we did before. We're going to use our hands up in the sky to figure out the distance between the top and the bottom star of the Southern Cross. Now, with this image right here, you can see the Southern Cross there. Use your own hand to try to figure out how far away the top and bottom star are. Using the ones we tried before, remember? Or using whatever you need to figure out the distance between them. If you want to just do this on your own, figure it out. It doesn't matter. Try that, remembering to keep your arm all the way out. If you do it like this, it's not going to work. Keep it all the way out. Measure 4 times that distance, just like we see here. 1, 2, 3, 4. That one's not to scale. This one is. You measure 4 times that distance. That tells you the point in the sky where you go straight down to the ground, and that is south. That point in the sky is called the celestial pole, and that point in the sky never moves. Everything else moves around it. You can also, of course, look at the top and bottom star of the Southern Cross, and you draw a line between them. Then you look over at the 2 pointer stars on the left, Alpha and Beta Centauri. You look at a point between them, and a perpendicular line going down where they intersect is very close to the south celestial pole. It's all mathematics. It's geometry and trigonometry. And Aboriginal and Islander people have been doing this for thousands, tens of thousands of years. You want to learn about amazing mathematical systems, you look to Aboriginal mathematical systems. There's something kind of cool you can tell about navigation, though. Not only does that tell you your direction as far as south, but this is really important when you use your hands. How high is that point in the sky above the horizon? That's when you really want to make sure you got your hands and you're doing this correctly. How high is that star above the horizon? Because that will tell you your latitude. Anybody know the latitude of Melbourne? Anybody know what latitude is? Nobody knows what latitude is? Somebody does. What is it?
Like how high something?
How far below the equator something is. So how far away between the equator and the South Pole? We're about 38 degrees, something like that, right? So if we were to go out, maybe you're in the middle of Port Phillip Bay for some reason, can't imagine why, but maybe you're lost out in the middle of Port Phillip Bay, fishing trip gone awry, and you look up at and you see that point in the sky, you use the Southern Cross and the pointers, and then you figure out, okay, well, how high is that above the horizon? And you work it out, you're like, oh, I'm 38 degrees. That's what you would have here. In the Northern Hemisphere, y'all seen the surfer symbol, right? You put your thumb on the horizon where your tip of your little finger is. That is the latitude of the big island of Hawaii. So what everybody thinks is a surfer sign is actually a navigational sign. And one of the last cool things about it, we can use the Southern Cross to tell time as well. So we have to look at everything in a pair. Everything has to do with space, and everything has to do with time. So if we look up at the sky right about now, this time of the year, July, we're into August now, as soon as the sun sets, we're going to see the Southern Cross sort of angled off at the sky like this. But each night at the same time, you're going to notice it being in a different position, tracing out a giant circle over a year. Melbourne is in a fortunate position. When we look at the Southern Cross, it never sets below the horizon. It is always in the sky, day or night. We call that circumpolar stars. And as we go further south towards Antarctica, towards the South Pole, we see those stars getting higher and higher and higher in the sky. But if we go north, we see them getting lower and lower. What does that tell us? It's one of about 1,000 different reasons that we know the earth is round, right? So who's heard about the whole flat earth thing? Please tell me nobody's dumb enough to believe that. Thank you. Thank you. All right, I have hope for the future. So this is something that Aboriginal and Islander people have learned a long time ago, especially Polynesia, because people go up to Hawaii in the north, all the way down to Rapa Nui, Aotearoa, and everything in between. And as you cross over the equator, stars that you couldn't see before, you can see. And the stars you could see disappear as you go back and forth over the equator. So you can look to the stars to help find your way across land and sea. You can use the stars to help know how to orient yourself, how to find the cardinal directions. There's a lot more to it than that. But I think this is a nice little way of being able to figure out how to find the 4 cardinal directions. So if you're down here in Melbourne and you can't see those stars of Bayes-Zum at all, they're all below the horizon, how are you going to find north? You find the south celestial pole and you go exactly opposite, right? How many degrees is that? 180 degrees. Good. You guys know math better than some of the undergraduates I have. Excellent. Fantastic. So we're going to end there, and we're going to just think about when we leave today, going out tonight, having a look if the sky is nice and clear to see what stars you can see in the sky. And you can see the Southern Cross tonight. You know where it's going to be. It's going to be up off towards the right when we're looking south. And see if you can find the south celestial pole. And see if you can, with using your hands, figure out how high that is from the ground. And does that match up to the latitude of Melbourne? If you do that, you might be able to find your way if you're lost in the bush.
All right. Hi, everyone. Obviously, all of that is really cool and exciting, and there's so much to learn. Duane's just got a very small snippet of a snippet of a snippet of some of the things that we're able to teach and learn here at the University of Melbourne. But for those of you online and those of you who are here visiting from schools, how do you get to know some of this information? How do you get to connect with some of the amazing work that's happening here at the University of Melbourne and lots of different places, particularly showcasing Indigenous knowledges? in the STEM area. And that's why I'm presenting today, and our team is here. We're going to talk a little bit about how the university's been doing that, particularly in the Faculty of Science. It's great that there's so many wonderful knowledge holders and academics that know all these things, but for some of us who maybe don't know about latitude or longitude or haven't grown up, even though, so myself, I'm a proud First Nations woman from Australia, also Polynesia, but I've grown up here in Melbourne on Wurundjeri country, so I haven't spent as much time out in the ocean as my ancestors have, but there's still things I can look up and know from the stars and continue to learn from my ancestors and old people, but also from academics who get to even do more research and do that as well. So one of the ways we try and share that with the wider community and you guys from schools is through some outreach programs. And one of them is called the Melbourne Indigenous STEM Education Program, or MySEP for short. And it's a series of workshops that our team have developed where we kind of theme it, gather a bunch of interesting information, hands-on activities in different workshops that showcase lots of different Indigenous STEM knowledges from all over the continent. And so some of the stuff that you would have learnt today would have been focused and shared in our Sky workshop. And so I'm just going to give you a little bit of a preview of what that looks like. So when we go into schools and we share a little bit about, we'll share the Sky workshop, we tend to start with the first astronomers and what's in the sky. And like Jules mentioned in the intro, our Aboriginal and Torres Strait Islander people are the first scientists, particularly of these lands. And we look to there's some lino prints from the Torres Strait. We learn about different kinds of constellations. We learn about different kinds of stars. We talk about how, if you remember Duane talking about what's reflected on the sky is on the land. And so that very much has importance when you need to know when to hunt and what to gather and what things are in season and what things are not. And so we talk a little bit about the different constellations and, again, like Duane mentioned, depending on where you are and how you see the stars can determine whether or not you see a shark, whether or not you see an emu, whether or not you see a warrior, and it all has meaning. And so we go from that beginning intro into connecting, again, reiterating that knowledge that what is happening in the sky is reflected on the land and vice versa. And we particularly use examples, again, from a lot of the work that Duane does with communities up in the Torres Strait and also very famously the celestial emu from Gamilaroi country, which is in central New South Wales. And we talk a little bit about how that all connects, particularly with breeding seasons. And we talk about the importance of being able to see the sky and how the future of sky country we need to really think about, considering there's a lot of big cities like the one we live in where it makes it difficult to see the sky and what impacts that can have on the environment, but then also us being able to read the stars too. So we're going to do a little bit of that activity, that last activity together as a group in person. Sorry for online people, but maybe next year you can come in person. But before we move on, I just want to share this quote that's actually in Duane's latest book. And it is from Dr. Annette Esley, who's a First Nations Lakota woman from the Northern Hemisphere, not only an artist, but an astrophysicist. And she says that science is something that anyone can do and everyone has done. The process on paper is simple. Closely observe the world, test what you learn, and transmit it to future generations. Just because Indigenous cultures have done this without test tubes doesn't make them unscientific, just different. So I guess one of the biggest things that we hope to happen in doing the programs like MySEP is that you all gain a better appreciation for Indigenous science and that it actually is very much connected. We're very good mathematicians, as Duane pointed out. We're very good at many, many, many things and have been doing it for a lot longer than a lot of other places as well, particularly on the places that we have called home for thousands of years. And just because we're not in white lab coats doesn't mean we're not practicing science. You all probably practice science in different ways every day. And so this is a way that we can connect all of you with some of these knowledges and showcase some of the things that are happening at Melbourne Uni in your classroom. So I'll talk a bit about that later. But again, Masterclasses is one way to do it. Programs do it, and then maybe when you decide to come to Melbourne Uni and take some of Duane's classes, is another way to do it. But yeah, that's us.
Amazing. Thank you so much. Give a round of applause to Ellen and also to Duane. Thank you. Thank you to both of you. Amazing. Oh, I don't know if we've got many more slides, but I'll take it on. Thank you to both of you. That was fascinating. So we're going to move on to some Q&A. So as I said, if you're online, please go ahead, click on the link in the comments, and it'll take you to Slido, and you can ask some questions there, and that'll come up here. Also in the audience, I can already see some hands going up. Yeah, just put up your hand and we'll bring the mic to you. As we're waiting for some questions, I thought I'd just kick off just to find out a little bit more about you both. I know you've got some incredible work that you've shared with us, but maybe just share a little bit about how you really got into this field, just to give everyone a bit of an overview. Yeah, what led you to some of this work? Maybe start with you, Duane.
Well, I came here from the U.S. in 2003 when I was in university and wanted to come study in Australia. Growing up in the 80s, Australia was a pretty huge place in pop culture, and I wanted to come here ever since I was a kid. So I did it and had a blast, and I moved back a couple of years later, and I've been here since 2006, and time really flies by. Yeah. But when I came here, I remember asking about Aboriginal views of the sky, and most of the time when I'd ask about that, the comments were very dismissive. I thought that would be very strange. I thought, well, why? Why is there this idea that Aboriginal people don't have astronomy or science? And even though I was studying astrophysics, I decided to look more into that particular area and started researching and studying that. And it was really obvious. Of course, Aboriginal and Islander people have been practicing science for a long period of time. Just nobody was recognizing it. I thought it very strange that an American would be coming to do this, but here we are. But then it's not so strange, because a lot of us come from all around the world, from different cultures and different backgrounds, and it seems sometimes it takes somebody from a different place to come and ask the questions that need to be asked. And that's kind of how I got into it, and I've been happy to be working with and for the elders for a number of years, all around Australia and around the world, to look at the way that different people understand the sky. But part of that, of course, has been looking at the science embedded within those systems of knowledge, which is much, much deeper than anybody is given credit for.
Amazing. Thanks, Duane. And Ellen?
Well, being someone who grew up here in Melbourne, went to school here in Melbourne, but and I was a student at Melbourne Uni for a time, I probably got into this work out of personal interest, being that, I'm Māori and Aboriginal and Hawaiian and a bunch of other things. And the more I've been able to reconnect with our knowledges, and it's definitely been something that I didn't really love science when I was in school, just FYI. It didn't really call to me at the time. But I will say that as I've gotten older and reconnected with my own Indigenous STEM knowledges, I have so much more of an interest in, it's like Western science. We could talk about that and debate about that for a long time. But I just think that there's so many wonderful things that I grew up with, culturally and traditionally, that I also didn't think was science. I just thought was the way that we did things, and have gained a greater appreciation for my ancestors and the wonderful scientists that they are. And I love being able to go to schools and share that. So that's how I'm in the work that I'm doing. Yeah.
Amazing. Well, I can tell that both of you love the work that you do, which is also an incredible part. Thank you for sharing that. So I believe we've got one question in the audience already, so I might hand over to you.
So I have two questions.
Oh, okay, two questions.
Yeah, Ash. So the first one is, what are your main motivations to keep creating and discovering in this field? Oh. And my second one is, what is some advice you'd give to everyone? Just in general.
So the first question was?
Main motivations.
The motivations?
For continuing to discover
love
this
it.
world. Yeah.
I mean, I know it's yeah, I was one of the nerdy kids in school, You guys probably pick on us, but you know what? I had a lot of fun learning about that kind of stuff when I was young, and just never got rid of that passion. It's always been something that's driven me, but I've always been interested in cultures and how we as humans connect to the stars and how we understand that. So it brings in science, it brings in culture. They're both the same, really. Science comes from culture. So it's been a fascination to learn from the elders how it all works and why it all works. And even though I've been here for 20 years, I still find it amazing, because it still feels like it's so much different from where I grew up, that it's a fascinating topic to keep learning about. So not only am I excited about it, I get excited when I see younger generations getting interested in science and culture and wanting to learn about that, especially young Aboriginal and Islander students. But also the communities keep inviting me to come work with them. And I love doing this kind of stuff, so that's what keeps me motivated and keeps me driven.
I mean, I would just add to the same. I think I love being able to see, all of you get excited about these knowledges. And I mean, we have vested interest. But to see, I mean, my hope is that everybody's able to gain a greater appreciation for Indigenous knowledges and how much sophistication and intelligence our people have always had that maybe hasn't always been appreciated by certain parts of society. But I find that working with young people, you're always so much more open and accepting of that. So the earlier that we can do that, hopefully it just means that future generations, it's like not even going to be an issue. Like, of course Aboriginal people have done this for ages, or Torres Strait Island people know what they're talking about. So again, it fills me with confidence that, the more that we can engage with you when you're in school and a bit younger and it's more widely known and understood, hopefully the less resistance comes when we try and, do this work.
And your second question was about advice? Anything
Was that
specific?
about uni or study
like working
or?
through school?
Just in general, like life, but just like more specifically in this like specific industry.
In the science industry? Yep.
I would say never think I can't do it. Never, oh, I'm bad at math, so I can't do that. So was I. So what? You can overcome that. Not everything is maths, right? But you don't have to be afraid of it either. Never think that I don't come from the right background, that I'm not smart enough, that I'm not good enough. That's what's going to knock you down. So aim high. You probably get there. Maybe you won't, but if you don't aim high, you might not get there. If you don't aim high, you definitely won't get there. So if you're interested in science or one of the STEM areas, give it a shot. Go, have fun, enjoy it. Follow your passion, and just don't lose sight of what drives you, what motivates you.
Yeah, and I would agree. I think you don't, like I mentioned, I didn't know I would be interested in science. And there's actually a lot of academics at the university who work in science and are scientists. And they said, I didn't like science when I was in school either, but somehow have found their way to it. I think the best thing you can do is find out what you're good at and what you really enjoy and see how far that will take you, and you'll end up where you need to be. Yeah.
Amazing. Thank you. Okay, we might move to some questions online which are coming in. So thank you so much, everyone. Duane, this one's, potentially both, but I'll start with you, Duane. So are you aware of any other cultures around the world navigating using stars and their hands?
Lots of cultures around the world do this because you need some kind of device to be able to measure things and figure out where stuff is. You can develop different tools for doing that. Some cultures will use knots on strings, which you think, well, how does that work? But it's pretty cool and innovative ways of being able to utilize different things. But just using your hands is quite phenomenal. So lots of cultures do that. And if you start to look at astronomy in a cultural context, you're going to notice that a lot of different cultures all around the world, separated by space and time, had very similar techniques, very similar ideas, and very similar perspectives on even the same groups of stars. So it's something that's part of our sort of shared psyche, if you will.
Yeah, absolutely. Actually, that goes to something you said, Ellen, too, about different constellations and how it's seen by different people, something that we talk about with MySep, I guess particularly with the emu in the sky. Did you want to talk a little bit more about that?
Yeah, I mean, we talk about a particular constellation that we know is like the Milky Way, you might have learned about in school, but from the northern hemisphere to the southern hemisphere, depending on where it sits in the sky, it could look like so many different things. But we talk about in the workshop that obviously, like if you're up in the islands in the Torres Strait, there's no emus up there. So when they look to that constellation, they're going to derive meaning from something that is in their area, which might be like a shovel-nosed shark instead. So I think it helps you know more about the localized area that you might now currently live when you understand more about what the traditional people of the land that you live on right now, when they looked at the stars, what did they see? Because if they see an animal that actually isn't around Melbourne anymore, you can go, what happened to that animal? You know? So I think, it helps you learn more about your surroundings and the area that you're in.
Yep. Amazing. Yeah. Thank you. So obviously there's a lot more in the workshop, no doubt. But great little introduction there. I'll go. Oh, one question up here. Yeah, great. Awesome. In the audience. Take it away.
When do you think Aboriginals started using stars and hand signs to like measure stuff?
Yeah. When do we think it all started?
Well,
do we know?
Duane's done the research.
Yeah.
I just go from what the old people have told us.
Well, I'd say since time immemorial, right?
yeah.
It's the very beginning. But if you even look at the scientific perspective about how humans migrated around the world and came to Australia, you'd have to have science to even get here, especially to cross the Wallace Gap. You don't just do things on accident. A lot of what's taught, or what used to be taught for a long time when people were found in places that were far away from where they thought they originated, they must have got there by accident. Maybe they went fishing and just a wind current blew them halfway across the Pacific Ocean, and they accidentally ended up on some island. That's not how it works. People understand how to read the environment, and this is something elders talk about, is reading the stars. How to observe and interpret exactly what you're seeing, changes in the positions of stars, or even the properties of stars. So you have to do that through observation, through deduction, through mathematics. That is something that it's a human characteristic. It's not from any one culture. All of us practice that, all of us utilize that. And we've been doing, people here have been doing that for tens of thousands of years. So I'd say before humans ever got here, if you want to go by that model, but as the elders say, we've always been doing that.
Yep. Amazing. What you just said actually connects to something that Beck has mentioned in Slido. I guess being blown off course and happening to sort of, I guess, come here. But how do people who travel far across the ocean or get blown off course, you said, navigate when they can't actually see familiar stars anymore? What if it's cloudy? Do you have any thoughts on other options they might have had?
If it's cloudy outside, which is not uncommon, right, you've got to be able to understand wind currents, swells in the ocean, temperature changes in the ocean. You look for animals or you listen for animals. And one thing that was really important is understanding and recognizing certain bird calls, because certain birds only go so far from land, and they may go out during the day. So if you're out during the day and it's cloudy, if you know how to recognize the sound that bird makes, you know that bird goes home every night. So if you recognize that bird and say, oh, it's this bird, figure out where it is, and then follow it home, you're going to get to land. So there's lots of ways of being able to...
Yeah, and I just did something not that long ago where we were doing some weaving through some Māori weaving. So Māori, the Indigenous people of Aotearoa, New Zealand, and again, master navigators. And we had to weave something that was like the shape of an albatross, which is a particular animal. And a lot of our ancestors knew if the albatross was near, that land would also be near. And so, again, some of our artwork and our songs actually have scientific knowledge within them that talks about how we utilised the environment to navigate where we needed to go. So it might be a nice song for you, but it actually has some really important information, for example, that continues to transmit knowledge. So, yeah.
Yeah. No, absolutely. And it is all about the environment, I think, from what you both said, being able to utilise everything you can possibly see and feel. Any other questions? Oh, yes, one. Okay, this is great. Go to the audience. Go for it.
How long has the Science Festival been, going for? Like, how long?
Oh, I mean...
Well, you've been here.
Yeah.
Sorry, you've been here for a long time, sorry.
Well, so Science Festival, this is the 11th year that University of Melbourne's done it for National Science Week. The actual National Science Week, which happens, across the country, that's been going for many, many more years, but I guess this is the university's way of celebrating it. And so, we do these masterclasses and then lots of other events as well, because so much science is happening in the university, but there's a lot of other places that do a lot of science as well. So it's a great week to celebrate what we do. Thank you for helping us share that. Yes. Did you want to do that, Taylor? Another one there. Yep.
Do you think views on Aboriginal and Torres Strait Islanders science has changed over time, or?
It's a good question. What have you found, Duane, in your research over 20 years?
How the public perceives it has very much changed. 15, 17, however long it was ago that I started doing this work, I got lots of strange looks from people when I talk about Indigenous science or Aboriginal astronomy. They say, oh, what are you doing? And then now people are really excited about it. People learning about it. People are engaging in it more now than ever before. So it's taken a while, but we've really pushed society in a big way to recognize the stuff that needs to be recognized. So.
And I'll add to, what I think also helps, what's been interesting is for our people, and I can't speak on behalf of everyone, but let's just say for me, we know what we know. Just because other people don't believe what we know doesn't change what we have known. We're sort of just waiting for everybody else to catch up. But what's interesting is the work that Duane does and a lot of other academics, whether they're Indigenous or not at the university, by showcasing and highlighting Indigenous knowledges and being able to put it in a form that I'll say, like, say, Western science or Western academia will accept or believe also furthers the ability. Not that we feel like, not that I feel I have to prove anything to anybody. Like, I know what my old people know and I will listen to them. And years later, everybody will catch up and go, oh, you didn't just get blown from the ship over to this random island. You planned that. I'm like, yeah, we tried to tell you that. But I will say that there's a lot of work happening where academics from all backgrounds who get to connect with these knowledges are able to show, and we're talking about sky today, but there's so many areas of Indigenous science and innovation that had been done for a long time, but wasn't regarded highly enough from certain parts of society. And as more research is happening and more showcasing to see, actually, no, that is what we've known all along. That's also starting to break down barriers as well. So we're just waiting for everyone to catch up, is really what I would say in a general sense.
Yeah.
But this work that Duane and other people do to continue to share that and show that through different other research methods that say academia accept also help change perceptions as well.
Great question. And yeah, so the fact that it is positively changing, I think, is a really good thing. Thanks to both of you. Oh yes, okay, great. Over there.
What made you interested in astronomy?
Over to you, Duane. A little bit more.
I grew up out in the country in the middle of Missouri and looked outside and just loved it. I don't know, it was one of those things. I think a lot of us, when we're really, really young, we're kids, we get fascinated with things like stars and dinosaurs and stuff like that. And what tends to happen with a lot of people, and unfortunately it tends to happen around the age you guys are coming into, you start to lose a bit of interest in that and your focus is on other things, but just keep that passion, that fascination with it. I just love being able to go out and see the stars. It's hard to kind of connect and want to be an astronomer when you're in the middle of a city because you want to be able to connect with things, right? But when you have clear, dark skies, well, maybe you don't live in that, maybe you've got grandparents that live out on a farm or something like that, but you can get out of the city and see the stars, then it's really fascinating. It really just inspires this sense of awe, and that's what kicks it off.
Yeah, it's incredible. I think it is more challenging being in the city, but if anyone's looked up at the sky the last 2 nights and seeing the ginormous moon in the sky, that's been pretty incredible all on its own. Thank you again for the question. So there's a couple more online. We've only got a couple of minutes left, so thank you so much, everyone, for those questions. So I might just continue with these two. So one quick one, so from Mel, what constellations are seen from the equator? So obviously we've talked a lot about on this country. Are there any other that you know, I guess, that is also seen in the equator or something separate on the equator?
Well, the equator is the best place to see all of them. You can see all of them. If you on the equator, you can see all the stars in the sky. You can see all the constellations in the sky. It's as you go closer towards the poles that you get to see half of it, right? So we get to see a bit of stuff we can see in the northern hemisphere, and there are parts of the northern hemisphere that can see the Southern Cross, right? But yeah, if you're along the equator, you can see it all. That's the best spot for it, actually.
Yeah, amazing. Okay, so I've got one final, well, maybe almost a combined question. One from Joe. This is Ellen. Any resources or quick tips that students can use to learn about Indigenous Australian knowledges? And I'm actually going to combine it with another question. How do I find Aboriginal and Torres Strait Islander stories? Because I guess combining them too, I guess MyStep is a great way to learn about these sort of resources.
Oh, yeah.
But how else can people find
There's so
about
many.
it?
I mean, there's books. Like, you can find books about the Seven Sisters, like for kids, which is the constellation Pleiades or Matariki in Aotearoa. There's lots of books. There's actually the school here at Melbourne University, the Melbourne Graduate School of Education, have got a signature project called the Nanga Project, which you can look up, and it's all about resources to connect not just with the sky knowledges, but lots of Indigenous knowledges that are accessible for classrooms. So teachers, it's free. You can use them in your classrooms and forward them on to students. There's the First Inventors series on SBS. There's so many things on ABC, and like there's actually quite a lot of resources in terms of TV shows, documentaries, books. And online resources to be able to use in classrooms. So if you go to the MyStep website, you can get in touch with us and we can share some more. But otherwise, it's almost like once you start seeing it, you start getting connected and you realize there's actually so much So I reckon my advice would be start looking, and then, yeah, it will snowball. There's actually quite a lot out there.
Absolutely. And Duane, you've also got an astronomy website. Is that still?
Yeah, aboriginalastronomy.com.au, but all the stuff for Nanga is perfect because it's all.
You'll see
laid
Duane
out
in there,
different-
actually.
Yeah.
Videos of Duane as well. So yeah, there's a lot of resources out there.
Yeah.
Yeah.
Thank you so much. A great question, everyone, and I think that's probably something we can all benefit from. So we've got 1 minute left, and so time has wrapped up. So my time to say thank you so much to both of you. Thank you for your presentations and for all the extra insights that you've provided through these questions. And thank you all for the great questions online and in the audience. I think we've been able to cover quite a few topics there, so it's been great. So just to let you know, so the masterclasses will be held, so events just like this one will be held throughout the week. And if you'd like to attend another session, make sure you register via the link in the chat. And there are more details on the Science Festival website as well. So the next event is actually happening this afternoon at 2:00, and so we will be delivering that event from our Burnley campus. So there's a bunch of us that are going to be racing to the Burnley campus right now. That event is Bird Nests Around the World, Natural Wonders with Climate Cues. So just as fascinating, a different topic and something else to explore. So that's that. Thank you again. Thank you, audience in the room. Thank you, everyone online, for joining us, and we hope to see you again at another masterclass.